Hi everyone and welcome back to Maths and Physics, Mr. Simons. Today we're looking at grade 12 momentum from the Winelands September 2015 paper, and we're looking when objects join after collision, right? So there, as you can see in this question, you're going to have a boy and a skateboard traveling one direction, ball in another direction. Eventually when they make contact, they move together, right? So there you'll see for boy catches ball after boy catches ball, right? So let's look at the problem. A boy on a skateboard moves to the right at constant velocity. The joint mass of the boy on the skateboard is 50 kgs. Catches a ball with a mass of 0.4 kgs that's traveling horizontal to the left at a velocity of 6 meters per second. After the boy catches the ball, they both move to the right at 1.49 meters per second. 3.1, define the term impulse, 2 marks. Calculate the magnitude of the average that the boy exerts on the ball when he catches it. If he and the ball exerts a force for a period of 0.1 seconds on each other. Write down the principle of conservation of momentum for 2 marks. Calculate the magnitude of the velocity v of the boy before he catches the ball. So how fast was that traveling there, and prove with necessary calculations that this is an inelastic collision, right? So without doing it like we do it normally, it's requested. I'm not going to break it up and then patch them in. I'll explain, so just follow. So impulse, when we say impulse, we can say it's a product of the resultant force or net force acting on the object and the time the resultant force acts on the object. If you go look at the equation, F net delta T equal the change in momentum, right? So that in short is impulse. 3.2, calculate the magnitude of the average that the boy exerts on the ball when he catches it. If he and the ball exerts a force for a period of 0.1 seconds on each other for 3 marks. So time is given, so calculating impulse using F delta T equal my change in momentum, which is mass times a change in velocity, right? So my time there given as 0.1 seconds. The mass, right, to the ball 0.4. Final velocity 1.49. Initial velocity -6. Take note, it's going in the opposite direction. So this is moving towards the left. We're taking right as positive, therefore -6, and that there is moving towards the right, therefore positive 1.49. And I've used the mass of the ball because the ball I have both velocity, the final velocity and the initial velocity, right? If I punch that all in a calculator and I divide by 0.1, my force is 29.96 newtons. 1 mark for the formula, another mark for correct substitution, and another mark for final answer, right? Let's go to the next question. Right, 3.3. Write down the principle of conservation of momentum. One of those favorite definitions they like asking. So the total linear momentum in a straight line of a closed system, 1 mark, remains constant, or we can say is conserved, 2nd mark. Right? 3.4. Calculate the magnitude of velocity v of the boy before he catches the ball. So we have to test whether you can work with the momentum equations. So number 1, we have to specify that we take right as positive or left as positive. Entirely up to you. Right, so 2 objects. Therefore, the sum of the momentum or initial momentum must equal the sum of the final momentum. Momentum before must equal momentum after. Right, so therefore mass 1 times velocity 1 plus mass 2 times velocity 2 initial for both of them must equal there, because they together, mass 1 plus mass 2 times final velocity. So mass 1 is 50 kgs, we don't have the velocity. Mass 2 is 0.4, and 6 is going to the left, therefore -6, right? Then we have mass 1 plus mass 2 because they combine, so that's 50 plus 0.4 times 1.49. Right, so there I have 54 times 1, 50.4 times 1.49. If I take negative 2.4, if I multiply this out over, it becomes plus 2,4. Add that and divide by 50 and we get the initial velocity of 1,55 meters per second. That is for the boy on the skateboard. Alright. Now, let's look at the next question. Right, prove with the necessary calculations that this is an inelastic collision. So number one, in an elastic collision, we should remember that kinetic energy is conserved. The velocity I had before must equal my velocity after. In an inelastic collision, my kinetic energy is not conserved. So my initial velocity and my final velocity would be different. So we look here, we calculated this object's, the boy on the skateboard's initial velocity is 1,55 meters per second. But after he catches the ball, it becomes 1,49 meters per second. Now let's say via calculation, so for elastic and inelastic collision, we'll always use kinetic energy. Right, so kinetic energy initial equal half mass 1, velocity 1 initial squared. Ne? Remember, it's now kinetic energy, so velocity squared. In momentum, velocity is just v. Plus half mass 2, velocity 2 initial squared. So half is the same as 0,5, mass 1 is 50. Initial velocity 1,55 squared plus mass 2 is 0,4 times the half, which is 0,5. And my initial velocity going to the left, negative 6 squared. There, if we substituted all of them correctly, we get 1 Mach. Multiply out on a calculator, we get 67,26 joules. All right. Now, if we look at the final kinetic energy after the boy catches the ball, equation half m1, m1 final squared plus m2 v2 final squared. So we have 0,5, mass is 50, velocity 1,49 squared plus the same on the other side, 0,5, 0,4 for the mass of the ball and the velocity 1,49 squared. And there my kinetic energy after he catches the ball, 55,95 joules. Therefore, kinetic energy initial not equal to kinetic energy final. Therefore, it's considered an inelastic collision. Right, so there's roughly about 12 joules of energy lost. So if I ask you an exam, where was this energy lost? It can be in the form of sound, meaning when he caught the ball, there was a sound made. So to make sound requires energy. Or he could have lost the energy due to the fact that there was some friction between him catching the ball and the ball coming stationary and moving with him in the opposite direction. Right, so I hope you understand. Wish you nothing but the best. God bless. Bye.